Does our universe truly represent the entirety of existence? Or is it merely a fleeting moment in an eternal cycle of universes? English physicist and Nobel Prize winner Roger Penrose has a compelling answer to this question. He is convinced that the universe is subject to a continuous cycle of destruction and rebirth. But that's not all. Penrose believes he has found solid evidence for his cyclical model. Specifically, the English scientist has identified a series of peculiar Hawking points in the microwave background, possibly the remnants of supermassive black holes from a previous universe. What is now common knowledge in cosmology was at best a curious idea just a century ago. In fact, until the mid-20th century, most scientists believed that the universe was eternal and above all unchanging. Of course, stars could be born and die, planets could collide, and civilizations could rise and fall. However, on a grand spatial scale, and over immense periods, the assumption was that the universe always maintained its fundamental appearance. Then, at some point, cosmologists realized that distant galaxies are moving away from Earth, and that the speed of this cosmic recession increases with distance. After many detailed follow-up studies, researchers finally uncovered the true cause of these odd galactic movements. Strictly speaking, the galaxies are not moving through space at all. Instead, it is space itself that is continually expanding. This revelation led scientists to understand that the universe is expanding, and that the idea of a rigid, eternal cosmos was no longer tenable. However, it wasn't until the 1960s that researchers realized this expansion, when viewed retrospectively, leads to a singular dynamic phenomenon. The universe originated some 13.8 billion years ago, as a result of the Big Bang. Such a radical cosmological revolution had perhaps not occurred since the heliocentric model was accepted. While we now know that the Sun is by no means the center of the entire cosmos, it merely marks the center of our solar system. Similarly, the groundbreaking recognition of the Big Bang brought with it several profound questions. If the universe truly began with the Big Bang, what came before it? What did existence look like before it began to expand? How long did it remain in this primordial state? Adding to the mystery is the principle that everything with a beginning must also have an end. What will the cosmic finale look like? Roger Penrose and the eternal cycle of the universe. Although these profound questions are as old as the Big Bang theory itself, we still have no definitive answers. Even in theoretical frameworks, there is no consensus among scientists. The astronomical research community is split into two camps on this issue. For example, Stephen Hawking believed that asking what existed before the Big Bang was as nonsensical as asking what lies north of the North Pole. According to him, since time itself began with the Big Bang, nothing could have existed prior to it. On the other hand, Roger Penrose presents a different approach. As a theoretical physicist, Penrose collaborated with Hawking during the 1960s, and together, they made groundbreaking advances in the study of singularities and black holes. In 2020, Penrose was awarded the Nobel Prize in Physics. Well, at least half of it. He received his share of the prize for proving that the formation of black holes is a robust prediction of general relativity. The other half went to Reinhard Genzel and Andrea Ghez for their discovery of a supermassive black hole at the center of the Milky Way. If we set aside the Nobel Prize honors and return to the main topic, we see that Penrose initially approached the question of the origin and fate of the universe from a philosophical perspective. To begin with, Penrose sought to define what constitutes a universe and what does not. Ultimately, his conclusions can be summarized as follows. The primary characteristic of a universe is motion, which in turn requires the presence of at least two material or energetic objects whose distance changes over time. However, if there are none or only one of these objects, we are dealing with an exclusive space that cannot be measured. In other words, it becomes impossible to determine whether space is infinite or whether it has been compressed into a singular state. Ultra-little volume, as in the case of a phenomenon in this setting, causes ideas such as speed and time to completely lose their meaning. According to Penrose, it can be assumed that the universe will one day return to such an extreme state, from which it can explode into its new existence. In a very distant future, the last elementary particle will have decayed, and the expansion of space will have obliterated the last photon. In this model, the universe will continue to expand until all matter has decayed and turned into light. This peculiar environment, in which nothing has any time or space reference to anything else, finally paves the way for another Big Bang. Just to clarify, according to Penrose, this is by no means a galactic anomaly, but a universal pattern that repeats itself over and over again. As mentioned at the beginning, Penrose is convinced that the universe has a cyclical nature characterized by destruction and rebirth. But if the eternal recurrence of the universe is real, shouldn't there be some tangible evidence for it? Well, according to Penrose, such evidence actually exists, and we have already discovered it. Do Hawking points originate from a past universe? In detail, Penrose, along with Daniel and Christoph Meissner and Paweł Nurowski, has identified a remarkable signal in the cosmic microwave background CMB that should reveal the true nature of the universe. Both the Planck and WMAP satellite data contain several circular spots, each roughly the size of the full moon. But what do these spots have to do with the cyclic universe? And why did scientists overlook them for so long? Essentially, the CMB is a remnant from the early days of the universe, created around 380,000 years after the Big Bang, during the so-called recombination epoch. In fact, this background radiation still permeates the entire universe today. Since its existence was predicted by the Standard Model, its actual detection is considered compelling evidence for the Big Bang theory. In line with this, Penrose now argues that the detection of the so-called Hawking points is compelling evidence for the cyclic model. These spots correspond to anomalies in the CMB temperature fluctuations. Both the Planck and WMAP data identified these anomalies in the exact same locations. Until recently, they were overlooked because it was believed that cosmological inflation would have completely erased such features. A brief explanation of cosmological inflation: scientists refer to a period of extremely rapid expansion of the universe following the Big Bang as cosmological inflation. While this burst of expansion lasted only a fraction of a second, it is thought to have increased the size of the universe by a factor of at least 1, 0, 26, 10, 26. To put it more clearly, the region that corresponds to the entire observable universe today initially had a diameter far smaller than that of a proton, and then suddenly expanded to a diameter of 10 centimeters. The cyclic models also recognize such periods of inflation, with one key difference: they find these periods in the time before the Big Bang. In other words, inflation results from the exponentially expanding distant future of a previous epoch of the universe. As mentioned, in the cyclic model, there is an infinite sequence of such epochs, each marked by its own Big Bang. The Big Bang of each epoch marks the continuation of the exponentially expanding distant future of the preceding epoch. Interestingly, the transition from one epoch to another is consistent with both mathematical and physical principles. After all, the conformal compression of the cold low-density distant future aligns with the conformal expansion of the hot, dense Big Bang of the following epoch. The exception of supermassive black holes. On paper, there is one notable exception: supermassive black holes. At the end of the universe, they would have already consumed the galaxy clusters in their vicinity before they, too, eventually evaporate into Hawking radiation. However, due to the so-called conformal compression, all the emitted energy transitions into the subsequent epoch in the form of a single Hawking point. The photons created in this process dissipate in an expanding region, but only become visible when they finally appear in the CMB of the following epoch. To us, the corresponding region would appear as a circle, roughly the diameter of the full moon. It seems that we can indeed see such an effect in the CMB sky. The mysterious spots could mark the locations where the black holes of the previous universe left their Hawking points in the background radiation. Debate among scientists. However, whether these observations genuinely represent a cosmic obituary is still hotly debated among scientists. Roger Penrose remains steadfast in his belief in the concept of a cyclic universe. To his critics, He responds that black holes were once dismissed as mere mathematical curiosities, but as we all know, we are now wiser. Who knows which of today's unresolved theories will one day become scientific consensus? And now, you can become a subscriber to our cosmic content. Feel free to click the like button and subscribe, so you never miss another video from us again. We'll see you soon.